Okay, so I'm going to talk about digital color systems. And when we're dealing with digital color systems, what we're trying to do is to put numbers on color. So how do we assign a number to a color? That's the challenge. And before we can put a number on a color, we have to put some sort of order on it. So in the beige envelope there, you have some color chips, and I want you to put them in order. So if it goes up there, do that. So they're all different shades of blue. And it doesn't take very long. Just be careful because the backs are white. So just make sure you put them all white. There's more in the envelope. That was too easy. That was too easy. So most of you have put black at one end and white at the other, and then the shades of grey in between. There's a natural order there that's fairly obvious and fairly intuitive. And so we can gauge shades of grey based on where they might be on the scale. So you might have black at one end, white at the other, and then the shades in between. Depending on where it is in the scale, we give them some sort of number. Now you can have, more or fewer or more shades of grey depending. But that's the kind of scheme that you'll be using. So you can put an order on it, so you have a range. And we can say, for example, this colour here is lighter than this colour. So this one here is more bright than that one, say. When it comes to colour though, it's not quite as simple. So in the coloured envelope, we've got some colour chips. We've got two. Yeah, doesn't matter. Yeah. So these are from the Be careful again because the back side. So you want some kind of an order as best you can. I cut off the names because I did this once before and some smart ass decided to do it alphabetically. So it's not as easy, is it? Like, orange is different from green. We can accept that, but it's hard to say orange is more of something. It's more or less of what? Like, orange is more orange, green is more green than orange, but it's hard to say anything more than that. I was hoping that some of you, and one of you did, break out from one line.
Yeah.
And sort of figure out maybe it's not a linear thing. Maybe it can't be done in a straight line. I've cheated here, and the example I've used could be done in 2 dimensions. But in reality, you actually need 3. There are a whole bunch of different ways of describing colour numerically, but all of them use 3 separate values. You need a minimum of 3. And what we're going to look at is the red, green, blue system, or the RGB system. And what that does is it assigns 3 values to each colour based on how much redness is in it, how much greenness is in it, and how much blueness is in it. So you've got 3 variables on the go. It ranges from 0 to 255. Anybody know why? Tom probably knows. Well, in 250, 0 to 255, you can have 256 possible different values. And you get that with 8 bits of memory. So sometimes when you hear someone talking about 24-bit color, it's because there's 8 bits for the red, 8 bits for the green, and 8 bits for the blue. That's where so 0 is the minimum and 255 is the maximum. So you might think of it going from 0 to 100%, but in actual fact we have 256 possible values. So if the red is cranked up fully, and the green is 0 and the blue is 0, then you get red. If you have no red, maximum green and no blue, you get green. And obviously, if you have no red, no green, and maximum blue, you get blue. So looking at these here, when the red and the green are turned up fully, you get a shade, you get pure yellow. As the green is reduced, you see that the red starts to have more of an influence on the colour. And so these different shades of orange. If we were to turn the green off completely, we just have pure red, as we saw here. So it can be hard in the beginning to get a feel for what the colours might look like. Also, if the red and the green and the blue are equal, you get a shade of grey. So we're kind of on familiar territory there. No. So this here, the red is turned up fully and the green is turned up fully, so we get pure yellow. What do we think this might be here? So the red value always comes first, always next, second the green, then the blue. So the red is at 255, that's maxed out. So the maximum amount of red, and the green and the blue is fairly low. So it's the green and the blue values are so low, it's probably not even worth worrying about. So it's merely going to be nearly pure red. What about this one here, 0, 0, 100? So red, green, and blue. So blue is winning here, isn't it? Blue is dominant. Do you think it'd be light blue or dark blue? When the values are high, it's going to be brighter. And when the values are low, it's going to be dark. So I'd say it's going to be a darkish blue, I would think. That's very dark. What about this one here now? It's a tricky one now. What if it was 200, 200, 200? That'd be a light grey, wouldn't it? So this is a light grey with the blue cranked up a notch. So it would be, it's nearly light grey, but the blue is edged ahead. So I would say it's kind of a pale blue, I would think. Okay? So I'm more than enough, we'll leave them. I think I'm low on time. On the front of your envelope there, there's an RGB value. See if you can figure out which of your colour chips might be that value. So green is winning. Green, actually, that's too easy because it could really only, I suppose, be better. So think, is it light or is it dark? Green. What about you? So yours red is winning out. So it's certainly red-ish. So that's a tough question then. Could be that or that, couldn't it? Okay. No, your red and green and blue values are all the same. So what does that tell you now? If the red and green and blue are identical, what does that tell you? If red and green and blue are the same, what do we know about that? Shade of grey, is it? So I think I have here. I think that's roughly what your colours were. So this 50-50-50 has to be shade of grey. Here, the red is winning out. No one had that one, did they? No. And here is a shade of green there. Now it's actually complicated by the fact that you have the interaction with the projector here as well, and the light in the room and stuff. So that's the idea. So you represent the colour with 3 different values. One value represents the redness, one the greenness, and one the blueness. If all the values are the same, it's a shade of grey. The higher the values, the brighter the colour, and the lower the values, the darker the colour. Any questions?
Thank you.